guys good? Everybody okay?
Somebody left there. I don't know what this
I think it's Will. I think it's Will.
I don't know. I think you keep women from getting pregnant or something.
Oh, wait, there's girls in the room.
All right.
Okay. All right. So, section 14.3 is basically, Professor Dagon went through the really long, painstaking way of finding average rate of change at certain points. We all know how to take derivatives. We've gotten this far. So now we're going to start taking partial derivatives of functions that have multiple variables. First, I answer the question of what a partial derivative is, because I had a lot of people ask me that. A partial derivative is just the derivative of a multivariable function with respect to one of the independent variables. So you can take the derivative of some function with respect to x, with respect to y, etc., etc. And so I give you guys the notation. All right. These all mean the same thing. You're given a function in terms of both x and y as independent, or as independent are your input variables or whatever. You can write the partial derivative in one of like these four ways. There are actually more ways than this to write them, but I found that these were the most, like, I guess, straightforward of them. This is the notation we use, or at least in differential equations, we use this notation.
You can use this notation here as well.
Okay. What that is I looked it up. I thought it was supposed to be delta, but it's not. It's just a curly D. It's not even that. It's just literally called a curly D.
Yeah, but we call it del.
Right, del, but it's not like, it was derived from delta. Thanks for that. It was derived from delta, but it's not. Delta's a little bit fancier. Okay, so the rules of taking partial derivatives. Say we want to find the derivative with respect to x of our function f of xy. We regard y as a constant and differentiate everything else with respect to x. So y is basically the same thing as a 5 or a 2 or a 7 or whatever. Just with respect to x, that's just that partial derivative. You're also going to take another partial derivative with your other independent variable. Like, you could have 300 independent variables, and you could take 300 partial. I mean, you would never do that. I hope you would never ever do that to us. But like, personally, I would cry. But you just regard with respect to that. You're with respect to variable. That's all you're really dealing with as a variable. Okay. So my example is number 25 out of the book. Find the first partial derivative of this function with regard to s and f, or r and s. First partial derivative is literally just taking the first derivative. There are second partial derivatives, etc., etc. You just take so many derivatives through. Not a big deal. I picked this one because it was not the easiest one, but we also got to use chain rule and no, we don't actually have to use L'Hopital. We use chain rule and product rule. Yeah. So what I did first was I took the derivative, the partial derivative with respect to r of our function. I just used it as an operator. And so we get r times 2r, which would be the derivative of the inside over r squared plus, I mean, I'm assuming you guys can follow this, then plus 1 times the natural log of r squared plus s squared. Everybody okay with that so far? Again, we've gotten this far. And then I just simplified it a little bit. So that would be the partial derivative with respect to r of this original function. Then I did the same thing with s. So basically, obviously the partial derivative with respect to s is a little bit nicer and cleaner, but it's not. Right, exactly. So, I mean, we could. Right. Yeah. So it's just really, it's really nice, it's really clean, it's really easy. It's not nearly as scary as all of this notation looks. Yeah, you see this and you freak out. It's literally just the same thing. But it's not. It went away. That's it.
You can continue if you want. I'm very comfortable sitting there.
I could have prepared the whole lesson if you would have.
Really good job. Actually, yeah, you saved some of what I'm about to do. It's a good example.